Okay, for this table, we're kind of copying what they're doing right here. 5 to the 3 means 5 times 5 times 5, and 5 to the 6 means there's 6 5s down there. Now, because we know that 5 divided by 5 equals 1, we can cross out that 5 and that 5, because 5 divided by 5 is 1, right? And looks like we can do this 2 more times. We can cross out that 5 and that 5 and that 5 and that 5. So those all go away. Why? Because if you have the same number on the top as the bottom, it's going to give you 1, right? In fact, I can write it like this. 5 times 5 times 5 divided by 5 times 5 times 5. What does that equal? 1. So it's like this thing is just like nothing. Okay, so this right here gives you 1. So what do I have left over? I have 1 on top and 3 5s down here. You guys said 3. You were right. There's 3 5s on the bottom. And how would you write that with an exponent? 1 over 5 to the 3rd. And that's correct. Now, but yesterday, remember we found other shortcuts? You guys remember the shortcuts yesterday? What do you do with exponents when you divide?
You subtract them.
You subtract them. Okay, so if we use that shortcut, we would say this is 5 to the 3 minus 6, right? Because we go top minus the bottom.
Wait, where did you get that 6?
The 3 and the 6, they came from here. 3 minus 6.
I thought it was the right of those.
Okay. No, I'm skipping this part right here, and I'm using my shortcut.
Oh, this is another shortcut.
So what do you get? What is this equal?
-3.
5 to the negative 3. So what I'm trying to show you guys is that this right here is the same as this right here.
I felt this in algebra.
Does that make sense to you guys?
Oh, no, never mind.
So a lot of you guys are using the shortcut, which is awesome. If I use a shortcut for this next one, for this one right here, it's 3 minus 8. So I'm going to write it out. We have a to the 3 minus 8. What is 3 minus 8?
-5.
So this is a to the negative 5. That's good, because that's correct. Now let's do the other one. It says x to the 4 minus 10. And what does that equal?
-6.
X to the negative 6. Okay. These are correct. Okay. But what the whole thing that you need to understand is how to write those with a positive exponent. And so to help you understand like what it looks like for a positive exponent, we can take this and we can expand it to see what's left over. So this is the last one I'm going to expand. I'm not going to expand the next one. So a times a times a. On the bottom I have 8 a's, right? 1, 2, 3, 4, 6, 7, 8. Man, I hate a's because sometimes my a's start looking like 9s. Yeah, so I'm crossing these out. So there's 3 at the top that I cross out, 3 on the bottom that I cross out, and I'm left over with 1 over, and I'm going to do the shortcut. How can I write this with the exponent? A to the 5th. Okay, so that means this is the same as this. They're the same. One has a negative and one has a positive exponent. But the positive exponent's on the bottom of the denominator, right? So what would the shortcut be for the x's right here? Like what would this one be with this one right here? What would that be with the positive exponent?
1 over x to the 6.
That's it. Okay, so that is what you do with negative exponents. You guys see? Understand? So you see right here, this right here, I mean this would be good to highlight because it's bold. It says negative power property. What is a negative power property? The negative power property says that if you have something like this, 1 over a to the n, what would the exponent be for this a? Yeah, -n. Very nice. Okay, so that's the property.